Thank you for joining us today for this month's University of Wisconsin Division of Extension Badger Dairy Insights, a monthly webinar series offered on the third Tuesday of each month. Badger Dairy Insights provides the latest dairy-based information to improve animal welfare, breeding and genetic selection, automation and modernization, and nutritional decisions for producers, dairy workers, managers, and agricultural professionals. My name is Heather Slusser, the dairy educator for Marathon and Clark counties, and I will be your host today. Since this is a webinar format, please use the Q&A button at the bottom of your screen to submit any questions or comments. As this webinar is being recorded, we will send you a link to the recorded webinar within a week, so you can share it with others you work with. Remember, sharing is caring. Our speakers today are Dr. Paul Fricke and his PhD student, Whitney Brown. Whitney grew up on a dairy farm in Belleville, Wisconsin. She received her bachelor's in dairy science from UW River Falls in 2019, her master's in animal science from the University of Wyoming in 2003, and she is currently in her second year of her PhD with Dr. Paul Fricke. Dr. Paul Fricke was raised on his family's row crop and dairy farm located near Papillion, Nebraska, where his family continues to farm today. Dr. Fricke joined the faculty in the Department of Dairy Science at the University of Wisconsin-Madison on July 1st, 1998. His research program focuses on understanding the biology underlying the numerous reproductive problems encountered in modern dairy cattle. Dr. Fricke has authored or co-authored 109 peer-reviewed journal publications, 145 abstracts, and 6 book chapters. Whitney, at this time, I would like to turn it over to you.
All right. Heather, thank you so much. Thanks for having us. So I'm going to start out here and just get us kicked off. And I want to do a little bit of background to kind of set Whitney up for the presentation that she's going to give. And this is some data from a review article that I wrote, published with my colleague, Dr. Milo Wiltbank. And in it, what we're looking at here, the line you're seeing on the screen, this purple line, is the phenotypic trend in days open from 1955 to 2020. And of course, with days open in reproduction, we want shorter days open rather than longer days open. So shorter days open is better. So you can see that there's this long-term trend from 1955 all the way up to the year 2000 when we see this long-term trend for increasing days open. That's reflective of poor reproductive performance or decreasing reproductive performance. But what you can see is that in the year 2000, there was a radical shift and we started to see a dramatic decrease in days open. So I call this period from 2000 to 2025 or to today, this kind of a quarter of a century, a reproduction revolution. And so we've been able to dramatically improve reproduction. And so one of the ways we've been able to do this in the box you can see there is by increasing the service rate. We can use timed AI programs. Most of our farms have bought automated activity monitoring technologies. So we have good ways that we can put semen into cows, which is the service rate. But Whitney, if you want to hit the button there, this is a trend that I kind of predicted that we would see, and it's something that we worked on for a long time. You can see the initial decrease in days open was not reflected by an increase in conception rate. Average conception rates up until about 2015 were in the mid 30% range for our lactating dairy cows. Over about the last 10 years, we've seen a dramatic improvement in the conception rate. And that's exciting. And if you want to just hit that button again, Whitney, I think there's two primary reasons for this increased fertility. It's the adoption of fertility programs like a double OVSync program, which actually increase conception rate compared to breeding cows to an estrus, as well as this concept of the high fertility cycle. And I believe I've done a webinar on the Badger Dairy Insight on the high fertility cycle. It's just that if we can get cows pregnant quickly after the end of the voluntary waiting period, they're going to not have long lactations. They're going to calve at a lower body condition score, and therefore they won't lose a lot of body condition, and that leads to better reproduction. So I think we've just seen this revolution, and it's had an impact on what farmers are doing as far as their breeding programs. So Whitney, just go to the next slide. So I pulled this off of an article from Hordes Dairyman in 2024. What that blue line is showing is the units, the millions of units of domestic beef semen sales. And you can see concurrent with about, I said about 2015 is when we started to see the conception rate start to go up. You can see it's kind of concurrent with that. There was a slight increase. And then around 2017, we see this dramatic increase in beef semen sales. So go ahead and hit the button there, Whitney. Of the 9.4 million units of beef semen sold domestically in 2024, 7.9 million units were used in dairy herds. That's based on the National Association of Animal Breeders. That was up a million units from the year before. And I'll talk about this on the next slide. Go ahead and hit the button there. Sex sorted dairy semen was at 9.9 million units in 2024. And if you hit it once more, conventional dairy semen was at 6.2 million units. So another concept I want to talk about here is sex sorted dairy semen and why people are using it. So go to the next slide. I just pulled this off of Dairy Herd Management, an article from June 5th. And this is a number that, we've all been discussing and that we're all very aware of. Dairy replacement heifers and beef cross calves are fetching record-breaking prices this spring, with Holstein Springers hitting $4,200 and beef cross calves surpassing $1,600. And so what we've seen over time is a dramatic change in the types of semen that are being used. These beef crossbred calves are extremely valuable, so people are using more beef on dairy. And then to take up the slack, they're using a lot more sex semen, even in the lactating dairy cows, but particularly in the non-lactating heifers. And I think this is going to kick us off really nicely to hear what Whitney has to say on some of the projects that she's been working through. So she'll go through the background. Go ahead and go to the next slide there, Whitney. We're very interested in replacement heifers, how they're grown, how they're reproductively managed. And so this was a title of Whitney's departmental seminar that she gave last semester. She's going to give us some background and talk about the latest data that she has. So I'm going to go ahead and turn it over to you, Whitney, and you can take it away.
Perfect. So as Paul kind of introduced, I'm working on looking at modifying heifers' reproductive synchronization protocols. This was the title of my seminar, The Modifications to a 5-Day CIDR-Synch Protocol to Improve Synchrony of Dairy Heifers for Timed AI. And I'm going to start off with a little bit more background, which is rearing heifers is very costly. Estimated about $2,355 from raising that calf from being born to entering the milking herd. And the majority of this cost can be found in the cost of what it takes to feed those animals. And this is one good thing because this is a cost that we can manage by getting those heifers to enter the milking herd sooner and decreasing that cost on feed. And one of these ways we can have them enter the herd sooner is synchronizing inseminations to decrease the times you have to breed them. And this study here from 2013, they looked at different reproductive synchronization protocols, but they found out that the 5-Day CIDR-Synch protocol is the best one for getting heifers pregnant and increased pregnancies per AI at 59% compared to the other two.
Yeah, and I'm just going to jump in there real quick, Whitney, on this. Just to remind everybody, that bottom protocol, that 5-Day CIDR-Synch protocol, that's kind of considered the gold standard protocol now. That's the one you're going to find in the Dairy Cattle Reproduction Council recommended protocols for dairy heifers. And that conception rate, 59%, just under 60%, is pretty typical, I would say, Whitney, for conception rates to conventional semen. So just a little bit of background on that. That's kind of the standardized protocol. Go ahead, Whitney.
And just looking at like a characterization of Holstein heifer fertility from 2006. So this is all conventional semen, and heifers had the greatest proportion was about around that 50 to 60% conception rate. So that protocol, that CIDR-Synch protocol, did not decrease the fertility. It was about average with normal inseminations across the US, and with that mean of 57%. And I'm just going to briefly walk through, as Paul described, the gold standard 5-day CIDR-Synch protocol. And this protocol has two main issues. The first is that in between our second prostaglandin and time day I, about 30% of heifers are going to experience estrus early, and so they're going to need to be inseminated early, which kind of defeats the purpose of a time day I program if you have to breed animals twice in the same protocol. And so to fix this problem, Megan, Paul's other student, looked at keeping this CIDR in for 6 days instead of 5 days. And the thought was, if we keep that CIDR in for an extra day, they're not going to experience that early estrus. And that is exactly what they saw. Those heifers here in the 5-day group in that blue color, about 12% came into estrus early, and about only 1% came into estrus early in that 6-day group. So the 6-day group eliminated that early estrus, and when looking at pregnancies per AI with that conventional semen, there was no difference between pregnancies per AI at day 32 or at day 67. So the next study was, let's look at this experiment, but with sex semen, because a lot more heifers are being inseminated with sex semen. So let's see what that looks like. And in this study, they had 3 different protocols. They had one where there was just a treatment of prostaglandin and then watch for estrus and inseminate. And then we did the 5-day CIDR-Synch protocol and the 6-day. And again, that 5-day had about 30% estrus detection in that blue color, about coming into estrus about 24 hours early, and only 1 heifer came into estrus early in the 6-day group. But when you looked at pregnancies per AI when they were inseminated with sexed semen, there was a decrease in fertility with that 6-day protocol. It was about the same as normal estrus detection, but something was going on with that 6-day group that wasn't optimal for sexed semen. And just a quick background of kind of why we think this might be happening is we remove, in the 5-day protocol, we remove the CIDR at that, the 5-day at the first prostaglandin, and about 30% will come into estrus early, so 48 hours later. Of those ones that don't come into estrus early, their estrus onset will be about 52 to 59 hours after that first prostaglandin. And then ovulation will occur about 80 hours after that first prostaglandin, which is 13 to 20 hours before ovulation is when you inseminate, which is optimal timing. But when we remove the CIDR at the second prostaglandin, we eliminate that early onset of estrus, but their onset for those heifers is pushed back to probably about 64 to 71 hours after the first prostaglandin. And ovulation probably won't occur until 96 hours later. So time day I is occurring about 20 to 27 hours before ovulation. So inseminating these heifers with sex semen, it just might not be able to, insemination is not good relative to when ovulation occurs.
Yeah, and Whitney, the one comment I would have here that I always tell everybody, one of the worst mistakes you can make with sex semen is breeding too early relative to ovulation. And as you've explained it here, that's exactly what we did by leaving that progesterone in for an extra 24 hours. We pushed ovulation later. We kept time day at the same time. So we're putting semen in too early for the sex semen. It dropped fertility by about 7 percentage points.
So this group from Ireland decided, let's see if we can improve this 6-day protocol. And they did this. They did the same exact protocol, having that CIDR in for 6 days, removing it at that second prostaglandin. Um, and so that was their control group. And then they tested just inseminating, giving that GnRH in the morning and then inseminating 8 hours later.
So they read our paper.
Yeah.
Yeah, they read our paper, and we basically speculated that this would be a good way to address that particular problem that you were talking about before. So they basically did the next experiment, which is great.
And they saw an increase in fertility with about 9 percentage points when they delayed that insemination. So we have found a way to fix that first problem of the 5-day protocol. And I mentioned that there was two main problems. And the next problem is that only about 25 to 40% of heifers will ovulate to that first GnRH. Ovulating to this first GnRH will help set them up well for the rest of the protocol, theoretically. And so we want them to ovulate there, but a lot of them don't.
And Whitney, a lot of people ask me the question, why don't they ovulate? I mean, in a cow protocol, at that first GnRH treatment, we will see ovulatory responses above 60%, 60 to 85%, I would say. There's two problems with heifers. Number one, they have more follicular waves, so there's a lot of times during a random stage of the cycle when there's not an ovulatory follicle there. But the other thing about heifers is they have higher progesterone. And when they have high progesterone, if there's a corpus luteum there, even if they have an ovulatory follicle, you don't get a big enough LH surge to cause them to ovulate. So that's the reason. Heifers are different than cows. We use different protocols with heifers than cows. And so you're setting up really nicely kind of the two major issues we have with this protocol. And so go ahead and show kind of what we were thinking to deal with this.
Yeah, so briefly kind of what Paul had said with our hypothalamic pituitary gonadal axis, our hypothalamus will release that GnRH. And then our anterior pituitary will release our gonadotropins, our LH and our FSH, and which will cause ovulation of that ovary. But if there's progesterone, that blocks that GnRH, LH surges. So we won't get that ovulation if there's a lot of progesterone there. And this was done in a study where they looked at GnRH-induced LH surge when cows had high versus low progesterone. And when they had high progesterone, they had a delayed increase, but mainly their surge was not as great as with high progesterone as it was with that low progesterone. So that low progesterone really allows for that LH surge to magnify. So how do we fix this problem of them not ovulating when we know progesterone might be high? And this study from 2019 looked at pre-synchronizing these heifers, giving them a treatment of prostaglandin 2 days before that first GnRH of the CIDR-Synch protocol. And so they looked at progesterone at G1, and they saw that when they were pre-synchronized, they had lower progesterone than those in the control group. And more of them ovulated to G1 from the pre-synchronized group, 86% versus 19%. And there was a tendency for pregnancy to be affected at day 32 and day 60 when those heifers were pre-synchronized with greater pregnancies per AI. So now that we have two fixes to this protocol's problem, this kind of leads into my study, which is going through my hypotheses, which is pre-synchronization with prostaglandin 2 days before beginning the CIDR-Synch protocol will increase ovulatory response to G1. And heifers submitted to a 6-day CIDR-Synch protocol with delayed insemination will have more pregnancies per AI regardless of pre-synchronization with prostaglandin compared to a standard 5-day CIDR-Synch protocol. And these are some heifers from one of the farms that I did my study at. They had some Guernseys, so I had to take some pictures. None of them were part of the study, but they're just
Yeah, we
cute.
didn't enroll any Guernseys, but maybe we should have.
Maybe. Um, so I had four different treatments. So heifers were either in our 5-day group, randomly assigned to receive progesterone or prostaglandin, sorry, receive prostaglandin or to be an untreated control. And then they would 2 days later receive GnRH with that CIDR insert, which was kept in for 5 days, and prostaglandin, uh, and then timed AI and GnRH there. And with our 6-day CIDR-Synch group, very similar. Our prostaglandin randomly assigned to either receive it or be untreated, and then 2 days later give GnRH, keep that CIDR in until that second prostaglandin, and then receive GnRH in the morning of breeding, and then inseminate 8 hours later. And throughout the study, I took blood samples at each time point, each treatment time point, and then I to look at progesterone throughout the study to see if they were synchronized. And then I also did some ultrasounds throughout the protocol to look at the follicular weight, the ovulatory responses. And just a brief experimental design, I had 2 farms that participated in the study, and heifers were randomly assigned to either the CIDR-Synch, the CIDR protocol, so either 5-day or 6-day with that delayed insemination, and then pre-synchronization, either they didn't receive it or they did. And there's about 280 heifers per main effect of this treatment. Statistically, I used general linear mixed effect models and for progesterone and ovulatory response and the pregnancy outcomes, having farm as a random effect. So to get into this, our results from our main effect of pre-synchronization on progesterone concentrations at the beginning of this protocol. So at pre-PGF, there was no difference in progesterone levels. But at G1, those heifers that received that pre-PGF had a significantly lower progesterone concentration than those that did not receive that pre-PGF. And then at PGF1, there was again no significant differences in those progesterone levels or progesterone concentrations. And when we go and look at the tail end of the protocol with our second prostaglandin and our GnRH2, at PGF2 there was an effect of CIDR protocol, and that is just because that CIDR in the 6-day group was left in until that day, so they're going to have higher progesterone concentrations than the 5-day group. And there was no difference at G2 in progesterone concentrations. I looked at ovulatory response with those ultrasounds, and this took about 30 hours of my time. There was 2,244 videos that I took throughout the study. I had a lot of undergrads help me go through all these videos that I took. And looking for those big ovulatory follicles and then seeing if they turned into CLs at the next scan. And when we looked at the proportion of heifers that ovulated to that first GnRH, there was a significant increase in heifers that ovulated when they received prostaglandin, that pre-prostaglandin. There was it basically doubled with that ovulatory response.
So Whitney, this is kind of a key result here, right? I mean, this is your first hypothesis. 31.7% ovulatory response. If you don't pre-synchronize them because they have higher progesterone, you get progesterone down, that's a big increase.
Hmm.
Double ovulatory response. We're getting it into the lower end of where we would see in a lactating cow protocol. So this is good. This is what we were trying to accomplish. So this is really kind of an interesting aspect of your study here.
Yes. When we looked at the proportion of heifers that ovulated to the second GnRH, so the breeding GnRH, there was no significant differences between the combination of treatments at this time, which I kind of expected this to be a little different, but it was not.
Yeah, and also we talked about this yesterday a little bit. I kind of would have expected those ovulatory responses to be in the low 90s, low to mid 90s, but they're
Mhm.
sitting right in the mid to high 80s. So again, I think it illustrates that these protocols in heifers are not they're not like the protocols we have in lactating cows. They don't synchronize them as well. So that's really your challenge, Whitney, is to figure out how to get these heifers to synchronize better.
Yes, it's a big challenge. So when we looked at pregnancies per AI by treatment, um, there was um, at day 32 and day 60, there was an effect of CIDR, and that's just because this 6-day group that was not pre-synchronized was very low with their pregnancies per AI. Um, but overall, there really wasn't an effect of um, the treatments on pregnancies per AI at day 32, day 60, or on pregnancy loss between day 32 or day 60.
And actually, if you look at that, the big thing we're looking at here is this what we would call an interaction. Certainly, for the 5-day treatment, pre-PGF had no effect on pregnancy outcomes, but in the 6-day protocol, that's your interaction, right? It seems that there
Hmm.
was an effect there, and improving it by giving that prostaglandin up front. So that's kind of interesting. And then pregnancy losses across the board are very low. That's typical for heifers.
Yes. So from my hypothesis with that first one, where we expected pre-synchronization to increase ovulatory response to G1, we accepted this hypothesis because that's what happened. We saw that big increase, 30% to 60% between those two groups. And in my second hypothesis, where we expected that 6-day CIDR-Synch protocol with delayed insemination to have more pregnancies per AI, regardless of pre-synchronization, we had to reject this hypothesis because we didn't see that um, uh, they were they were different. So summary, our pre-synchronized heifers had decreased progesterone concentrations at GnRH1. Our 6-day CIDR heifers had greater progesterone concentrations at PGF3 or 2. Um, and this was just because of that CIDR being left in for that extra day in that 6-day group. And then our pre-PGF heifers had greater ovulatory response to G1 than heifers that were not pre-synchronized. And for future directions for me, I'm doing a large scale fertility trial this summer, kind of trying to look more into this nuances of these protocols. And I'm also working on doing a characterization of dairy heifer management on Wisconsin farms, um, working on that this summer. And all the people that helped me, the farms that allowed us to do this study, and my lab members, and all the undergrads that helped.
All right, Whitney, that's really great. Thanks for taking us through that. Really, this is your first kind of major field trial, first attempt to try to look and see if we can improve these protocols. We were able to get double the ovulatory response. It doesn't seem to be, maybe that's not the rate limiting step. We still need to kind of play around with this. I think the study that you're going to do later this summer is a large scale trial. We want to have 400 or 500 heifers. You had about, would you have about 100 and How
40.
many? 140 for each
Yeah.
group? Yeah. So some of the things that we're seeing in your current data set, just because we have low numbers of heifers, it's more of a physiology trial where you took a lot of blood samples and scans to try to see what's going on in the ovaries. But I think once we get past this study that you're going to do later this summer with bigger numbers, we'll have a better answer as far as whether the pre-PGF is really improving fertility or not.
Yes.
So that'll be exciting. Look for that. So anyhow, Whitney, thank you for taking us through that. And if Heather's still there, you can kind of wrap us up here.
Yes, you didn't lose me. I am still here. So I put it in the chat, but if anyone has any questions at this time, I don't see anything in the Q&A, but I'm sure Paul and Whitney would love to answer some of your questions. So feel free to type them into the Q&A, or if you can't find it, I can see you in the chat as well. So I'll give you guys a little bit of time to get your questions typed in. While you are doing that, I would like to invite you to join us next month on July 15th for our next Badger Dairy Insight. The topic is how can nutrition help us in taming inflammation and improving cow health? To register and learn more about next month's webinar, please visit go.wisc.edu/Badger Dairy. All right, so there is a question that just popped in for you
Hmm.
guys. I knew if I talked long enough, we'd get one. All right, so how applicable
Oh
is this
boy.
to dairy goats?
Okay, so dairy goats. This is an interesting question. This is from an anonymous attendee. Um, I am not an expert on reproduction in dairy goats. What I can tell you is that OBSYNC type protocols do work in goats. But I'm not sure whether the modifications that we're looking at to the protocols, and I'm not even sure if they're modified protocols in goats for an OBSYNC type protocol. So I'm going to kind of punt on that question a little bit but I do know that OBSYNC like protocols, they do use them in goats to synchronize them. So interesting question. Anything out there with dairy heifers or lactating dairy cows? We'll have to have, yeah, we'll have to do it. We've got a new paper out, Heather, I was going to mention on timing of insemination, which might be a really good topic for a Badger Dairy Insight at some point as well. So,
Yeah, that sounds good. And honestly, I look forward to hearing more about the results after Whitney's summer project and getting
yep.
more animals in there. So, yeah. All right. Well, I don't see any more that have popped in. Whitney, if you want to go to the next one, I can wrap us up, but
It wants to. There we go.
there you go. All right, so for more information on unbiased university-based dairy resources, please visit Extension Dairy Program on the web. You can also scan the various QR codes there to reach us. We also have a QR code for the Badger Dairy Insights, which will take you to the registration page if you are not signed up for the July one. You can also subscribe to our Dairy e-newsletter, which is always chock full of valuable information. So don't feel shy. Make sure you check us out. And again, we are also on Facebook. So thank you for joining us today. Thank you, Dr. Fricke and Whitney, for being with us. And Whitney, thank you so much for sharing your research and what you have going on. I took 2 pages of notes, so I appreciate it.
Yeah.
So awesome. Thank you very much.
Thanks.
Thank
It's been a
you.
pleasure.